In this video, I introduce cross-state partial networks. Each state of DenseNet contains a dense block and a transition block, as shown here. Output of the dense block is used as input to the transition block. Model parameters and gradients are updated by using two sets of equations. This is for feature update, and this is for gradient update that reuse the previous gradient. Where f is a function of width and gi is a gradient propagated to the dense layer I. Cross-state partial network is a technique to improve performance of deep convolutional neural networks. For example, CSPNet separates base feature maps of DenseNet into two parts. One part passes through a dense block, while the second part is used as a partial input to the transition block by skipping the dense block. A stage of CSPNet is composed of a partial dense block and a partial transition block, as shown here. In a partial dense block, the feature maps of base layer x0 in a state are split into two parts, x01 and x02, where x01 directly links to the transition block and x02 is input to the dense block. The model parameters and the gradient are updated by using two sets of equations. This is for feature updates, and this is for gradient updates that reuse the previous gradient. CSPNet preserves the advantages of DenseNet, but at the same time prevents the excessive amount of duplicate gradient information by reducing feature maps of the base layer to half. One purpose of CSPNet is to increase the gradient path to reduce the gradient vanishing. Through the split and merge strategy, the number of gradient passes can be doubled, which can alleviate the disadvantages caused by using explicit feature map copy for concatenation, and balance the computation of each layer by using only half of the original number. There are two different gradient fusion strategies. Fusion first, as shown here, concatenates the feature maps generated by two parts, and then conducts a transition operation, which reuses the previous gradient and reduces the gradient vanishing. In the fusion loss model, as shown here, x01 skips the dense block and the transition block. The port x01 is concatenated with the output of the transition block, which doesn't reuse the gradient since the gradient flow is truncated by transition block. For more details, please check with these references. Thank you. Bye.